So I've had several email questions in the last couple days about question 7, chapter 9, from chapter 9, section 1. And so I thought I would start with a couple of things to help out. First of all, if you go to current content on our course site, files associated with test 1, assignment assistance, I've already built one Excel file to help with one of the things that the assignment is asking, namely gathering every 5th data point. And the other thing we want to do is go get the lecture demonstration, if you don't have it already, for 9.1, which is this middle file here. Alright, so we're going to open that one, and that one, and take a look at the problem now. So a key factor in the world's economic condition is the population growth of the region. The accompanying data table contains data for all the world's 232 regions. So there's a lot of data right here. And I'll come back to that in a moment. So it says, from this population, suppose a systematic random sample of every 5th region is selected, starting with the 5th region on the list. From the sample, test the null hypothesis that the mean population growth between the years 1990 and 2000 is equal to 1.55 tests using alpha equals 0.1. All right, so several pieces to this. So we're going to do a hypothesis test, and in this case, there's nothing said about sigma, so this is a sigma unknown. So let's see, it might be this one. Is that the only sigma unknown? Sigma unknown. Oh, okay. Yes, it is. So we'll have to adjust this one. So I'm going to copy this one out so I'm not messing around with this. So this is homework 9.1, question 7. So we have that, and I'm going to get, there we go, and I'll just plain old move this one, since, there we go. So I'm going to come back, grab the data, and we'll just paste it right here in A1 with Control V, or you could have hit that icon. Now the way this works is I take the rank and divide it by 5 and have Excel compute the remainder. The remainder, for example, 5 divided by 1 is 1, 2 divided by 5 has a remainder of 2, 8 divided by 5 has a remainder of 3, and so on. And every time it's 0, Excel spits out every 5th one. So anything we need to compute from column D. For example, the average here is the average for column D. Going back to our template, we need the average, the population mean, sample mean, population mean, standard deviation, and count. So I'm going to come back here, actually bring this down, standard deviation, actually. So stdev.s of column D, and the count of column D. So now I can come over here and so X bar then is equal to this average here. I'll come to this in a minute. this is the standard deviation, and this is the count, and we get this. No, where did I put it? There it is. That took long enough. There we go. 1.55. So 1.55. Alright, so is it equal to 1.55? That means these are our hypotheses. Calculate the test statistic. We should be able to grab that right here. And it wants 2 decimals. And find the p-value. Scroll. Right here for 3 decimals. But let's take a look at the formula. You'll notice it's t.dis.rightTail. We need to change that right tail to 2-tail because it's a 2-tail hypothesis. And when I hit enter, it'll give me a number error message. That's because it only takes positive values for input. So to make sure it's always positive, I'm going to do that, include the absolute value, and so then we've got 0.006 for our p-value. If p-value is less than alpha, reject. This is definitely less than 0.1, our alpha, so reject, there is sufficient. And then find the population mean. Well, that's the average of everything in column C, so we can just say equals average, column B, average all of column B to 3 decimals. And I'll let you guys figure out the last problem. And there you go.